video, we'll explain how to set up and solve a Leontief problem with three sectors. It is none of the problems in the common set or in the notes. Let me first of all write the problem. So we're assuming here we have three sectors: agriculture, industry, and services. And the assumptions regarding the consumption among the sectors are as follows. To produce one output in agriculture, output of €1, we require 0.1 euros from agriculture, 0.1 euros from the industry sector, and again 0.1 euros from the services. Regarding the requirements of the industry to produce €1 of output, we have that is 0.01 euros from agriculture, 0.2 euros from industry, and 0.02 from services. Finally, services will produce one output of €1 using 0.2 euros of agriculture, 0.25 euros of industry, and 0.2 euros of services. The external demand are equal to 1 million for agriculture, 2 million for industry, and 3 million for services. As usual, we have to compute the production in each of these sectors, so the external demand is fulfilled and they are not excellent. At this moment, you should stop the video, copy down the data in a piece of paper, and try to set up this question yourself. So pause the video at this moment. With the Leontief problem that I assume you have at least copying a piece of paper. The total production in agriculture, I'm going to denote it by X. In industry, I'm going to denote it by Y, and services will be Z. In this case, if we look at the requirements, we can express to produce X output in agriculture, we need 0.1 X from agriculture itself, meaning we eat 10% of what we produce. We need 0.1 X from industry and 0.1 X from services. The requirements are expressed in terms of X because the more agriculture we produce, the more requirements we have. But this has to be done. For example, this has to come from agriculture. Comes from agriculture. While this one comes from industry, and the last one comes from services. So setting this up, we have the production in agriculture, industry, and services. And we have, of the production in agriculture, 0.1 goes to agriculture. Then the production of industry will do 0.1x, which corresponds to this second one. And this is 0.1x. If we look at the other data, what we have is that for Y, the requirements are here. You have them here at the requirement for Y will be 0.01, 0.01 Y, and then 0.2 Y, and 0.02 Y. Finally, for services, we have plus 0.2 Z, 0.25, and 0.2 Z. And let's put 1 million, let's put in 1, 2, and 3. And that's the system. So we can solve it as I have done in class in two different ways. One is putting the identity matrix, but let me put it simply, moving first everything that has an unknown to the left hand side. So we have x minus 0.1x minus 0.01y minus 0.2z equals to 1 million. Y minus 0.1x. This is very boring. You should do it yourself while I'm doing in the video because it's, well, boring. Sorry, and on top of that I do a mistake. Here z minus 0.1x minus 0.02y minus 0.2z equals to 3. This system, we do the computations, it will be 0.9x minus 0.01y minus 0.2z equals to 1 million. The x is here, so it will be minus 0.1x plus 0.8y, that comes from 1y minus 0.2 minus 0.25z equals to 2, and minus 0.1x, which find here, minus 0.02y here, and the z are this and this, so will be plus 0.8z equals to 3 million. Now let's write the matrix of coefficient. B times x, y, z equals to the demand 1 million, 2 million, 3 million. So we have B is the matrix 0.9 minus 0.01 minus 0.2 minus 0.1. Again, these are the boring part which I could skip, but anyway, we're done almost. Here it is, the matrix. And the determinant of this matrix, if you compute it by hand or with a calculator or something like that, you see that the determinant of this matrix is equal to 0.55. And if you compute B inverse, you'll see that this is equals to 1.15, 0.02, 0.29, and let me finish it without reading. 0.03 and 0.44 and 1.3. Okay, a small warning about how to compute B inverse. Okay, to compute B inverse, you can use a calculator, or you can use any of the methods that you have learned from school, and I will explain in another video when I have the time. Just remind me in case I don't do it soon. To finish the problem, we look at this part here and changing to blue so it looks better, is B times the unknowns equals to the demand, or from here multiplying by B inverse we get the demand, the unknowns equals to B inverse times the demand. So that's a simple computation. Is this matrix here multiplied by the 1 million, 2 million, 3 million. You do the computation, you get x equals to 2069307.82. Y will be equals to 4042956.41, and Z will be 4109737.39. And that's the problem. I have even one page of paper down here that I don't need. And I'll stop here.